There are two types of technologies commonly used in science fiction, especially mass produced science fiction, that are the backbones of pretty much most science fiction settings by this point. But they both are soft sci fi, and in many ways make anything that's reliant on them a form of fantasy that has science fiction dressing. That makes Star Trek really on the same playing field of science fantasy as Star Wars. In fact, Star Trek is a major offender in both of these, and that is the use of time travel and faster than light. Time travel, I've actually encountered people in the real world who've tried to argue to me that it's actually going on and that maybe the aliens that are visiting our Earth are actually humans from the future and ridiculous things like that. It just takes a basic little bit of deductive logic. If time travel is practically possible, not meaning that it's possible on paper, but you can actually build a machine capable of doing it and harnessing the insane amount of energy is required to pull it off. If it's possible to be done, at some point in the future, it will be done and it has been made in use, and so can be said to have already happened. And since the universe is not unraveled, and there's not any other kind of paradoxical damage going on that is observant, it's a causality loop type universe in terms of time travel, which makes it kind of functionally useless. You can't actually change things. All it is just predestination curves and shit like that. Or you just can't build it. And the reason why, if it's not either practically impossible or a predestination curve type scenario, why it would unravel reality, is because all the information that makes up the universe, all the little bits of subatomic particleness that make up everything, all rest upon a bed of quantum entanglement. And introducing matter and energy that's out of sync, from taking it from one place and putting it into another place, out of sync on the forward trajectory of motion, would unbalance the quantum entanglement of the subatomic universe and potentially cause a ripple effect that would cause everything to just kind of unwind, fizzle. The universe would just be gone. And since that's potentially what have happened in our past, the universe would already be gone. I would not be here to explain to you why time travel is likely impossible and or at best highly impractical and useless. If time travel was potentially useful, if you could go back and alter events. The paradox is not just fucking your own grandmother type shit. The paradox is mathematical. You'd be adding matter and energy, even if just a small amount. And in that area, everything that's atomically trying to keep itself afloat and manifest to keep all these particles dense and having mass and having some sort of material shell that we can all perceive, while trying to pass through and interact with this alien matter, what's going to happen? I'm not saying this is all a guarantee, but the likelihood is high that it's going to have really bad effects at a subatomic level. And that's where we don't want things to have bad effects. That would be a real apocalypse. It would be something far more alien to the laws of nature than busting an atom in half with fission, which is arguably the first truly unnatural thing humans ever done. So anyway, don't worry about time traveling aliens from the future. If they could do it, they would have already destroyed the universe and we're here, so everything's cool. And or they went back in time and fucked their own grandmother. Who knows? Anyway, FTL. It's a time-saving device. If you want to tell realistic stories about humans traveling the stars, they're going to be very alien. Once again, I use that word to traditional human storytelling. Because either time is terribly distorted for the characters because they're traveling at just shy of light speeds, which in and of itself is nearly as impossible as reaching light speed itself, just in terms of power requirements, because it's a nice steady trajectory until you get to the end of the curve, and suddenly the amount of power you need to push up that last 10% goes way the hell up. And by the time you get to light speed, you're having to pump so much energy into your acceleration that you become energy. And since you can't reconstitute that energy once you get to your destination point, even traveling at light speed is just not likely to be in our future. Getting between the stars is going to be centuries-long endeavors, but that means telling stories that take place across centuries and having to either contrive semi-immortal characters or relying on the natural temporal distortion of just traveling at different speeds. See, in a way, time travel is kind of real, but we are the time travelers, and time travel is what we're experiencing by experiencing time. But it's always plunging forward in one direction, and even if you can vary the rate at which you experience it, you're still moving in the same direction as everything else, even though everything's expanding. But in terms of like the mathematics of it, you're still moving in the same fundamental direction as all the other material of the universe. And so therefore you're not disrupting what's there in the same way you would be if somehow you were to just skip, because you'll cause a void that has to collapse, and then you'll cause an intrusion at the other end. Don't tell me wormholes. Wormholes are minuscule. And once again, it's the power requirements. That's another fundamental problem with all FTL drive is the energy needed to break the laws of physics in the way that they're proposing. Like trying to say shit like antimatter. Antimatter is not going to do the trick. Antimatter is not nearly as dangerous as he thought it was. We had a little bit of antimatter contained. They decided to just let it fizzle out to see what happens. And it just fizzled out. Apparently, there's not quite the same amount of explosive effect as was theorized. So, it's just more like, a one-for-one cancellation. So Star Trek's antimatter drives aren't really going to get us there. You'd have to be having stuff that can put out the entire energy output of the sun. And it's still dubious. Like the people who like to cite the warp drive that NASA was looking into, unfortunately, the universe's positive-negative value keeps that from being possible. We're on the wrong side. If we were a positive universe, it might be possible, but apparently we're a negative universe. Man, does that make sense? We are the negative zone. Anyway, hard science fiction is largely just going to be set in our own solar system. And the thing I think that's kind of ignored with science fiction is high-tech sci-fi that's still largely on Earth, but in the distant future that doesn't have a lot of space travel. Because unfortunately, the real reality is it's expensive to get up there, and it's deadly as fuck in a lot of ways, and we might not ever be more than just little flesh creatures on our one planet, but with a lot of robotic feelers all over the place around our solar system, and maybe beyond. So maybe in the end, Transformers is actually the most realistic science fiction out there.